This is the screencast for section 2.4, example 1, long division. Oh, the dreaded long division. Well, first of all, let's talk about some terminology for division. I wrote some statements out here. These are the two ways you will see the concluding statements of division in this section written. First of all, you have fraction form. So this is your original problem up here, f of x, called the dividend, f of x, dividend, and that's the main function you're dividing. So when you divide it by the function d of x, that's called the divisor, then that will equal the q quotient, which is the result after dividing minus the remainder. Then you'll add the remainder divided by the dividend. Now, I'll show you an example of this, but basically the reason why you put the remainder over the dividend is because that's what a remainder is. It still remains to be divided by what you're dividing by. Polynomial form will be f of x equals your divisor times your quotient plus the remainder. So a really quick example of that would be, let's see, 7 divided by 2 equals 3 plus a remainder of 1 that still has to be divided by 2, so 3.5. Now if I take that and I multiply both sides by 2, I get the polynomial form. 7 equals, let's see, that would be 2 times 3 plus 1, the remainder. So the function, the divisor, the quotient, the remainder. Okay, when a function divides evenly, this vocabulary word in here, that means when your remainder is 0. So r of x equals 0, then a function divides evenly. So let's look at example 1, polynomial long division. So using long division to find a quotient and remainder when 2x to the fourth minus x cubed minus 2 is divided by that mess, 2x squared plus x plus 1. Write a summary statement in both polynomial and fraction form. So first things first, let's do some dividing. In long division, you're going to put on the inside the function you are dividing. So in this case, it's going to be long 2x to the fourth minus x cubed. Now long division is tricky. You have to make sure you have a place held for every term. So even though you don't see an x squared there, we're going to put plus 0 x squareds, because that's true, there are no x squares there, plus 0 x's, and then minus 2. Now we are dividing by 2x squared plus x plus 1. So what I need you to remember in long division is that we are only focusing at one term at a time. So I'm going to take this 2x to the fourth and I'm going to make this the focused term. How do you get 2x squared to be 2x to the fourth? Well, you simply multiply by x squared. So I'm going to put an x squared up above the x squared term just to keep things nice and organized. So now I need to do that. I need to multiply 2x squared plus x plus 1 by that x squared. So that would be 2x to the fourth. Let's see, x times x squared is plus x cubed. And then 1 times x squared is plus x squared. Now, next step would be to subtract. This is a lot of multiply, then subtract. Multiply, then subtract. So we multiplied to find out what these first terms would be. And we had to multiply by x squared, so I multiplied everything by x squared. Now I'm going to subtract. 2x to the fourth minus 2x to the fourth is 0. That is the way it should be, always. Negative x cubed minus negative x cubed is negative 2x cubed. Then we've got 0x squared plus minus x squared would be negative 1x squared. Now I'm going to drop down a new term, plus 0x. One additional term gets dropped down. I need 3 terms each time, so I have something to work with for each of these subtraction terms. Now the first term that I'm focusing on is this negative 2x cubed. How do you make 2x squared equal to negative 2x cubed? Well, you have to multiply by a negative x. So I put that as my next term up here. Now I need to multiply everything by that negative x. So 2x squared times negative x is negative 2x cubed. Positive x times negative x is negative x squared. And then 1 times negative x is negative x. Now comes the subtraction. Negative 2x cubed minus negative 2x cubed is 0. Again, exactly how it should be. Negative x squared plus x squared is also 0. Interesting. Now, 0x minus negative x is positive 1x, and I am going to drop down yet another term, negative 2. Now, because there were 0x squareds here, I can't really, I guess I would multiply by 0 to get this next term, to get 2x squared to equal this 0x squared term. Which means I'm at the end of the line here. 2x squared will never equal x by multiplying by something. So that is my remainder. So to write our concluding statements in our two forms, let's first work with polynomial form. Polynomial form is, states that 2x to the fourth minus x cubed minus 2 equals what I divided by times what I got. So 2x squared plus x plus 1 times x squared minus x, and then plus my remainder. So plus, I don't need to write the 0x squareds. It's plus x minus 2. That's polynomial form. Fraction form, I'm going to write the division I just did as a fraction. So 2x to the fourth minus x cubed minus 2 all over 2x squared plus x plus 1. I got, by doing that division, x squared minus x, but I had x minus 2 that left to be, remains to be divided by 2x squared plus x plus 1. So there is my fractional form of long division. The now try problem is example 1. When I set up the long division problem, I'm going to put in the inside the divisor x squared minus 2x plus 3, and on the outside is going to be x minus 1. Now I know the directions do not say you have to use long division, but because we are practicing long division, I am going to do example 1 with long division. Now, question is, what can I multiply x by to get x squared? Well, x. So I'm going to put an x above the x term, and I'm going to take x and multiply it by each one of these. So x times x is x squared, line that up, and then x times negative 1 is minus x. Now I have to do my subtraction. X squared minus x squared is 0. Negative 2x plus x is negative 1x, and then I drop down my plus 3. So now, x minus 1, how am I going to get that to be, how am I going to get the first term, x, to be the first term, negative x? Negative 1. I have to multiply by negative 1. So x times negative 1 is negative x. Negative 1 times negative 1 is plus 1. So now I've got to subtract again. Negative x minus negative x is 0. Good. 3 minus 1 is 2. I will never get x. There are no more terms to drop down, and I will never get x to be 2. So my remainder is 2. Therefore, polynomial form is written as my original function, x squared minus 2x plus 3. That equals, let's see, x minus 1, what I divided by, times what I got, which just so happens to be x minus 1 as well, plus an extra 2. What remained. So if I multiplied x minus 1 times x minus 1 and you FOILed that out and then you added 2, you would get x squared minus 2x plus 3. Try it, I dare you. Then, fraction form. My division problem is written as a fraction. The fraction I just did was x squared minus 2x plus 3. And I divided by x minus 1, so there's my fraction. I got x minus 1 plus 2 that remains to be divided by x minus 1. I couldn't finish that 2 divided by x minus 1. I had to leave that as a remainder.